Alright, so Wiley 6. I went through the background information for answering this. This is 6a. So we had 2-methyl 3 hexanone. And okay, again it says 2 pathways, and I really don't see why they said this because the answer, whatever. Alright, so let me just redraw this. Okay. This is the 2-methyl 3 hexanone, and I'm going to put the positive on the oxygen right here because these electrons, the lone pair electrons, are most loosely held, and they that's where it's going to be lost from. So the information that Wiley gives, they say it's going to fragment, right? And then you're going to have the fragment, which is going to be positively charged, right? And then you're going to have your neutral radical ion, a radical. And Wiley says that the neutral radical is C3H7. So what I did first is I calculated the MZ, the mass over charge, which gives me the molecular weight of this molecule. So what did I do? Okay, it has 7 carbons, so they're multiplied by 12. And then there was one thing, what was I saying? There's something I have to... Oh, okay, right. Okay, so there were 7 carbons times 12, so that's 84. There's 1 oxygen. I was assuming it was oxygen 16, but after doing the Wiley and typing it in, it's oxygen 18, which is just something you gotta figure out by messing with Wiley. So that was oxygen 18, so there's 1 of them times 18 equals 18, not 16. And then there's 13 hydrogens multiplied by 1 equals 13. 84 plus 18 plus 13 equals 113. So the mass over charge for the molecule that we're working with is 113, right? That's pre-fragmentation. Okay. Okay, so then what I also did is I wanted to see how much, okay, the radical that left, they told us, the radical that left C3, there was 3 carbons, right, and 7 H's. So times 12 equals 36 plus H7, there were 7 H's, times 1 equals 7. That equals 43. So then from this you can calculate with of course what the charged fragment's going to have. What's the charged fragment that's going to be detected going to have? This obviously won't be detected because it's not positive. So it was I'm sorry. When this was 18, I had it as 16, so this is 115, not 113. It would be 113 if this was oxygen 16, but it's oxygen 18, so it's 115. So the charged fragment is going to equal minus 43. So, well, that's how we would represent the charged particle, right? It's going to be this particle prior to fragmentation minus 43, the neutral radical that left. So from calculating 115 minus 43, 115 minus 43 equals, and M divided by Z equals, I wrote 70 because that's when I thought that oxygen was oxygen 16, but it's oxygen 18, so it's actually 72. Right, and then, okay, I just double checked that. Sorry to be tedious about this. Maybe I just double checked it by saying, what did I do? I said, what did I do here? 48. Never mind this. This is tedium. It got too crazy. Okay, so the reason that I did this is that Wiley does ask what is the mz for the charged particle, and it does equal 72. So if you're typing it into Wiley, it's 72, not 70. And then it asks for you to write the particle itself. So here I wrote, this is our molecule that we're dealing with, right? That positive is on the oxygen. Okay. So remember that background information that I looked up in order to be able to answer this with the psyllium ion and everything like that, with the resonance and all that kind of fun stuff that I did in the first part of this video. So what happens here is this carbon, this electron from the bond, this bond right here between this carbon and this carbon goes here, and then this electron goes to the bond here. The electron from the positively charged oxygen goes right here to this bond, and so that breaks off, and we are left with, we get the positively charged fragment that's being detected, whose M divided by Z is 72, and the neutral radical, which is CH3H7, right? There's 3 C's there and 7 H's. And then, of course, now in Wiley, in Wiley, only one of these was the answer, so I'll look it up in a second. But this has resonance, and the resonance is CH3, C plus. Remember, because one of this is a triple bond, right? Yes, this is supposed to be a triple bond. Right here, I'm sorry, this is supposed to be a triple bond, not a double bond. One of these triple bonds comes up here and goes to the oxygen, and that's how we get the resonance here with that. It's on the positives on the carbon rather than the oxygen. And I think it's this one that Wiley is accepting. Let me double check real quick. I'm almost certain that's the one that Wiley is accepting. And then, okay, so that's that. And then quickly, no, that's that. All right, okay. Thanks, bye.